Hello, today we are doing 8.1a. We're looking at exponents in Chapter 8, looking at first applying exponent properties involving products. Remember, product means multiply or multiplication. So here we have 7 to the power of 3 times 7 to the power of 5. Do not plug this in your calculator. We are not using calculators. We are simplifying, okay? Simplify. So what we're going to do is take a look at this and this. Both of these exponents, 7 to the power of 3, that's 7 3 times. I'm going to actually write it vertical. I'm going to make a little chart here. Oops, a little too far. And this is really multiplying 7 3 times 7 times 7 times 7. And on this side, this is really multiplying 7 5 times. 1, 2, 3, 4, 5. Well, how many times did we really multiply 7? We multiplied 7, 5, 6, 7, 8 times. So the exponent 8 tells you how many times we're multiplying the 7. So really, 7 to the power of 3 times 7 to the power of 5, the original problem, what we do is we really take our two exponents, the 3 and the 5, and we add them together to get to 8. Same thing if we take a look at the next one. If I make a little chart here, this is really 9 multiplied 1 time. This is 9 multiplied 8 times, 9 times 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 9. And then over here, this is 9 just 2 times. So how many times did we multiply the 9? Well, I'm going to count the big one first. 8 plus 2 is 10, plus 1 more is 11. We can also get that by adding our 3 exponents. You're just adding 1 plus 8 plus 2 to give you 11. 9 to the power of 11. That is our answer. We're not plugging it into the calculator. This next one, this is multiplied here. This is negative 5 one time. So here we have negative 5 once. And here we have negative 5 6 times. And the reason why I put it in parentheses is because we're multiplying negative times negative times negative times negative. So if we figure this out, we have how many times do we multiply negative 5? Well, we multiplied it 6 and one more is 7 times. We know that our answer is going to be negative because we have an odd number of negatives. These two would really make a positive. These two would make a positive. It will end up being a negative. But for right now, you can just leave it as negative 5 to the power of 7. You can also get that by adding 1 plus 6. You can do the same thing with just our x's, any variable. This is x multiplied 4 times. This is x multiplied 3 times. So how many times did we multiply x? Well, 4 and 3 more. We're just really adding those. Total of 7. So the first couple I would like you to show your work, but then if you understand the rule, you can just write the answer. These ones do get a little bit more complex. Think, like before we had x to the power of 4 or something, so we'd write out x 4 times. This, we now have this whole piece to the power of 3. So we're going to write that whole thing 3 times. 2 to the 5th, 2 to the 5th, 2 to the 5th. I wrote it 3 times. Just like the exponent here told me to write this 6 times or this 3 times, we wrote this 3 times. Now I'm going to create my little chart. This is really multiplying 2 5 times. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. And same thing here. 5 2's there and 5 2's here. So how many times did I really multiply 2? Well, 5 plus 5 plus 5. We multiplied the number 2 15 times. Another shorter way for you to get that, if we have the distributive property, meaning they're multiplied, 5 times 3 is 15. Shortcut way to get that exponent of 15. So same thing here, if we use that shortcut, these are touching, that means multiplication. Oops, M-U-L-T, multiply. We're really going to have negative 6 multiplied 10 times. If we wrote it out, we could write everything that's in the parentheses 5 times. So we could have written negative 6 squared, negative 6 squared. Wrote this out 5 times. And that will give us how many negative 6s? Well, each of these is 2 negative 6s. So we have 2, 4, 6, 8, 10 negative 6s, which is the same answer we got up here by just multiplying our two exponents. So if we wrote this one out, we'd write x squared 4 times x squared, x squared, x squared, x squared. And if there's an exponent, we can keep going. This is 2x's, 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 2x's. So how many x's do we have total? 2, 4, 6, 8. Not including these, we distributed them or multiplied them out, expanded them. We have x 8 times. Also, we know that these are touching. That means multiply 2 times 4 is 8. You get the same answer. Alright, for some reason my equal sign is a little off here. I don't know why that happened. We can write what's inside the parentheses, however many times it says on the outside. We can write y to the third 3 times. Oops, I don't know why that happened. Come on. Y to the third, y to the third, y to the third. I wrote it 3 times. And because we still have exponents, we can distribute or expand this. This is y 3 times, y 3 times, y 3 times. So how many y's do we have all together? We have y to the power of 9. Same thing here. If these are touching, we know that's multiplied. Y to the power of 9. Or at this point right here, when we have y to the third, y to the third, y to the third, we're really adding our exponents. 3 plus 3 plus 3 is 9. That's what we did back here. So when they're separated by that multiplication symbol, you're really adding the exponents. All right, let's flip over to the back side. The long way would be writing whatever's in parentheses 2 times, because it says the power of 2. So we can write 9xy, 9xy. If you want to put the multiplication in there, you can. So that takes care of that too. So what do we have? We have 9 2 times. Oopsies. 9 2 times. We have x 1 2 times. That's x times x is x squared. And we have y 2 times. Y times y is y squared. Because it's all multiplication, we can really multiply in any order that we want. So if you multiplied this out, 9 times 9 is 81. So another answer that would be acceptable would be, goodness, I'm struggling here, 81 x squared y squared. Or if we look back at just our equation, the exponent of 2 goes to each one of the letters and numbers. 9 to the power of 2, x to the power of 2, and y to the power of 2, because we wrote each one 2 times. Same with this one. We can give each letter and number in here the exponent, 7 to the power of 3, a to the power of 3, and b to the power of 3. That is your answer. If you wrote it out the long way, we could write out 7ab 3 times. And we know that this is really all multiplication, so we can multiply in any order. So how many 7s do we have? Well, there's 3. How many a's do we have? 3. And how many b's? 3. That's how we get the same answer. These next two are a little bit different, so you need to be careful. This one, the negative's on the inside. This one, the negative's on the outside. So the first one here, we're only writing whatever's in the parentheses 2 times. So we're writing negative 4z twice times negative 4z. This one, we have a negative, really a negative 1 times, and then we have 4z 2 times. 4z. So if we simplify this is all multiplication. We have negative 4 2 times. And the reason I put the negative in parentheses is because this is 4 squared and then negative. This means negative 4 2 times. A negative times a negative would really make a positive. And then times z to the power of 2, because there's 2 z's. If we multiply this out, negative 4 times negative 4 makes a positive 16. So our answer would be 16z squared. Where over here, Our z's, we have 2 z's. I'm just working backwards on this one. And our 4's, we have 2 4's. And it's also times -1. So if we multiply this out, 4 squared is 4 times 4 is 16. 16 times -1 is -16. So this one our answer is negative. This one our answer is positive because of the difference of where the negative is in relation to the parentheses. Alright, last two, a little bit different than the first couple we did, but same process. There are no parentheses, so I'm just going to draw a little table. We have a 6 and an R. Here we have an 8 and 2 R's. Since this is all really multiplication, you can put the dots there if you want. We have 6 times 8, which is 48. If they're different numbers, multiply them out. If it's the same number, you could write like 6 squared or 8 squared. And then we have R, 1, 2, 3 times we multiplied R. R to the power of 3. Again, this is really R to the power of 1, so we really just added our exponents and got 3. Alright, next one, I'm going to look at just this piece first. We have 2x to the power of 3, 2 times, 2x to the power of 3. Or you can give each one the exponent, but be careful with the x's. I'm going to copy this over here as well, x to the 4th. So if we still deal with this part in red, we have 2 times. We have x. This is really 3 x's. I didn't make my table. This is really 3 x's. So now we have x to the power of 6. And then this piece here, I haven't done anything with yet. So we just got rid of our parentheses. Notice here, when we have those 2 exponents, if the parentheses is there, that's really multiplying. 2 times 3 is 6. Or write it out. So now we have 2 squared times x to the 6 times x to the 4th. Well, these are all x's. We can really combine them together. This is 6 x's, and this is 4. So how many x's do we have all together? Really just adding our exponents. 6 plus 4 is 10. If you wanted to write 4 times x to the power of 10, that works as well because 2 squared is 4. If the exponent is less